Hi everybody, welcome back to Chem 140. We have a pretty short lecture today. In fact, there's very little that I need to go over for the lab review. So if you have any questions, go ahead and type them in the chat while we're going over the lab stuff for lab number 3. And I will go over those when I have a second to. Otherwise, this might just take like 15 or 20 minutes, and then we'll just be done, and you can go have a Halloween weekend. So, lab number 3 is being assigned this week, and lab number 3 is all about various properties of ionic compounds that we don't really get to talk about in the classroom because these are things that are better demonstrated, like in a live setting. So, what we did, and by we, what I actually mean is the other 140 instructor, Samita. She created a very in-detailed video of doing an experiment, and then I chopped it up into pieces and cut out about 2/3 of it. So that video is linked in this document right here, which you'll need to paste into your browser. So let me get that ready here for you real quick. I just broke it. Hold on. I hit next on accident and I suddenly got to Linus Tech Tips, whatever the hell that is. So that should work. We'll make this a little bigger. I can't imagine this getting copyright strike because I literally made this video. So this is the flame test video, which has Samita in here doing an experiment, and so I'm just going to click through here. During the video, there's going to be directions on how to do stuff, which obviously you aren't going to do. You're not going to adjust your Bunsen burner at home. This is more supposed to be a tutorial in the sense that I am future-proofing this course by having this video available. I might actually show this to students when I'm in a live classroom setting, just so they have it as a reference, and then when they come in the next day, they can see it. So you can pause this video whenever you want to, but the intent is that, and I'll play this without the audio on here. We're going to be taking this wire that you can see here. Somebody's just cleaning the wire here. And then what we're going to be doing is dunking the wire after it's heated up into a solution with ions. So here's the first experiment. This is potassium chloride. And Sami's going to demonstrate that you put a little bit on the dish, and then you put the hot wire onto that such that it gets sucked into the oxygen intake. Because if you heat water, it vaporizes, right? If it's a vapor, it can go into where a gas is, and you can see that there's a little slot right here. This is where oxygen is going in so that the flame up at the top can burn. We've got fuel coming in the hose and oxygen right here. And so when you heat this coil up, whatever is in this water will get vaporized, get sucked up into the flame. And then you'll see it in the flame when it burns. And every element has a characteristic color that is going to show. And so whenever this is warm enough, I'm just fast forwarding there. I might have fast forward past it. Okay. You can kind of see it. I think the next one, there we go. I paused the video. Okay. So I paused the video at various points so that you can observe the color of the flame. I'm going to do this so that you can see the color appear. There it is. And what you are allowed to do, and just in case you don't know this, if you use the comma, oops, hold on. So the comma button is back one frame, and the period button is forward one frame. So if you're confused and you don't really know what the color is because it's hard to see, what you can do is you can just sit there and advance the frames back and forth one at a time. I'm trying to get it to where it's actually playing here. Let me just show that. So we're going to do frame forward one frame at a time here. And you can see that it goes real slow. But this gives you granular control over YouTube. So you can advance the frame as slowly as you need to so that you can find the right frame that helps you describe the color the most. I'm trying to get it to go into the flame here, but because you can tell it's hard to do it on the taskbar when the video is so long. There we go. So if I just advance one frame at a time, there's the color. You can see it appearing. There's the color. You're going to do this for a bunch of different tests, and it's going to show you all of those in the video. So you'll play through that, and you're going to record your observations for the flame test. And so there'll be a table. Let me actually get the table here that you'll be working on. All right, so here's part A. Or sorry, this is actually pre-experiment questions. Here's part A. You're going to describe what you saw in this table. And then we're going to do some unknowns. Note that there are 3 unknowns. They're numbered 1, 3, and 5. There is no unknown 2 or 4. Your unknowns are going to match one of the 5 standards that I showed you in the video, or that Samita showed you. The colors are a little bit hard to see, especially if you have trouble interpreting color. So if you have like red-green color blindness, this is going to be very difficult for you to do alone. Make sure that you have somebody in Discord offer to help you or request help. I obviously can't do the lab for you, but you can rely on other people's observations, and then you can just cite there, like to the side, you could say, I am colorblind, so I asked for so-and-so to help me. And as long as you cite them, that's totally fine. You just have to give credit where credit is due, basically. So that's part A. Part B involves a conductivity test, which you can see right here. And what this is a probe that is connected to the computer, which has a number that represents how conductive the solution is. 0 means absolutely nothing is conductive. A high number means very conductive. Electricity only gets conducted through a medium if the medium can move electrons easily. The way that happens is if ions are present, because ions are charged particles, and electrons can either bounce across from one particle to another, or you can just move the charged particles themselves. Oh, excuse me. So the movement of charge, right? So if you don't have any charged particles, you don't have conductivity. And so what this experiment is going to do is test various solutions to see if they are conductive or not. Now, like we just said, if solutions conduct electricity, they must have charges, and so therefore there must be ions present. Now, what's considered a high number within the scale? I'm going to leave that up to you when you watch the video because it's very obvious. So, for example, this number that's shown right here, 13, we end up zeroing it out, so you can ignore this. But when you put the electrode into solutions that are ionic, you get a number. And if you put them in solutions that are molecular, you get a different number. And your job is going to be to compare those numbers together. And they're going to be real obvious what the numbers are. Okay? Alright, so that's part B. You'll just watch Samita go through the experiments. You'll record the numbers down into this table right here. And then I have a bunch of questions for you to answer afterward about them. Does the electrode machine give off its own conductivity? Not that we would measure. So 13 is just the background count for whatever water was used. Even perfectly filtered water is going to have some trace ions in there, and the detector is sensitive enough that it could see something. Oh, excuse me. But more likely, what is going on is that it's miscalibrated because it was just plugged in and it hasn't been calibrated yet. So what Samita actually does in the first second is she calibrates it and sets it to 0. So if I do this, and we go forward enough, there's the conductor. I'll play this part because I did some editing magic and I thought that it was kind of funny. So here's Samita.
Logger Pro program is also ready to measure, but notice how this window right here where it says conductivity shows a value of 13. We want to start with a 0 reading so that we have the correct baseline. I'm going to zero it out before starting the experiment.
There you go. It's magic, right? So that will be the base value, is 0. We're going to use 0 as our reference point and then test other solutions from there. Now, it is possible that if we put a solution in that was less conductive than what the reference solution was, it would become a negative number, which would not be super useful. But we're using distilled water and whatever is in distilled water as our background, because all the other solutions that were made were likely made with the same distilled water, plus whatever substance we added in there for the solution. For example, ethanol or sodium chloride or etc. And so as you go through the experiment, you're going to see different numbers in there. I'm just going to click over there. So there's an example of a number. Like, the numbers can be big or small. And if you can't tell what the number is, pause the video and then just make the video like full screen. So if I hit this, now it's bigger and you can see it because I can read it on the screen now. So I tried to get the video to be high enough resolution that everything was legible. So that's the video. It's 16 minutes long. You do not need to sit there and watch the entire 60-minute video if you just want to tab through it. And you're welcome. It was 45 minutes long. I asked Samita, can I borrow your lab videos if you've already done this one? And she was like, yeah, here you go. And I was like, can I make it shorter? And she said, well, sure. It's not that long, is it? Is it too long? I was like, yeah, it's too long, Samita. If you've had Samita's class before, you totally understand that her video is too long because Samita's like me. We want to talk forever, right? It's because we love chemistry. That's really it. That's all I have. So you're going to answer all these questions based on your observations and your understanding of the documentation. So make sure that you have... Oops, it's over here. Make sure you have read the entirety of the documentation. It's only 5 pages long, so this lab is actually pretty short. Importantly, it has some illustrations here that help you understand the difference between ionic compounds and molecular compounds in both the liquid, aqueous, and solid phases. So I think this picture is really helpful. I really should put this picture in my slides when we talk about molecular. And then just for fun, I gave you a list of like what colors are used in what fireworks. So when 4th of July rolls around, you can point at all the green fireworks and be like, hey, that's copper, and impress all your friends. Actually, blue is the copper one. Green is probably, what is green? Green might be like barium or something. You know what I could do? I could zoom this in and just read it off the paper for you. Barium nitrate or barium chromate. Yeah, that checks out. Anyway. Yeah, that's the lab. That's all I have. I told you take 15 minutes, right? So I'm just going to go, boop, there we go. This is where we live now. So, how are you? Good, good. I'm doing all right. If you have any lab questions or any questions about anything at all, I mean, I can make it even more creepy. I could just do this and that. That's just me. Goodbye. No, I'm just kidding. It got kind of lonely and creepy here. Hold on. Hey, you guys are back. Hooray. I need to make sure what is this? Oh, that's that. That's that. That's that. Okay. This is why I don't touch these things. I had it all set up, and then I turned them all off, and I was like, what? Now I don't know what anything is anymore. I even have them all labeled. I just don't know what the labels mean. So yeah, what I'm gonna do is I'm gonna pause for like 5 minutes. I'm gonna go get more water because I drank all my seltzer, and I'll let you guys accumulate any questions you might have, and then we'll start going over them. But if you don't have any questions, like that's really it. That's all I had planned today. We could talk about like Halloween or something. I am going to a Halloween party on the 30th. I don't know what I'm dressing up as. I'm probably just going to, I don't know, wear something fancy from the closet. I haven't been out for 2 years to like a party type situation. Like I've gone out with friends, like one or two, but not like a bunch of people. Like that was in the before time. So I don't want you to think that, oh, Wes is sad and doesn't have any friends. No, it's just that I'm staying the hell away from them during a pandemic. I have tons of friends. I just don't want to be anywhere around them when I could die by being exposed to them. So, you know. All right. I'm going to hit mute and shut up. Go ahead and type any questions you might have in the chat or just hang out. And then we'll sign off and go do anything else. I guess I could put the music back on. We'll do that too. I just realized that this is not technically correct. So this is we're not doing a lecture today. Today is lab worksheet number 3 and Q&A. There we go. That's a little too intense for a question and answer session. Let's change that. There we go. So, I'll just leave the mic on since I'm back. I got my seltzer water here. I got lime here. So the unique situation would be like, so carbon is kind of weird. Like, I'm trying to think of like unique but stable situations because in theory you could do anything you want to. Like, you can add electrons to a metal and you can remove electrons from a non-metal. However you want to. You just like use X-rays to add them or remove them. Carbon is probably the best example. I'm trying to think of how to explain this using stuff that we have talked about, because I immediately want to jump to oxidation number, but we haven't talked about what that is yet. In fact, we don't really talk about that until 163. I think since I'm back, we can get rid of the music here. Candy corn's kind of a sometimes candy, I think. Personally, I'm not a big candy corn fan past, like I'll eat like 4 or 5 pieces, and then I'll be like, you know what, I'm done with candy corn for a year, or something like that. Alright. Other questions, let me know. Yeah, the best description that I can really give is that for metals that accept electrons or nonmetals that lose electrons, it tends to be in situations where you only have nonmetals. So, like, if you only have 2 nonmetals together, one of them will want electrons more than the other. And that property is called electronegativity, and we'll cover that in 161. With metals, it's a very esoteric case. So, like, you can have metals in solution when you do organometallic chemistry where you have a charge 0, or even a charge that's negative, although that's very rare. But the vast majority of metal conditions are forming some sort of cation. Like, platinum bounces between platinum +2 and platinum +4. I know a lot about platinum because that was what I did chemistry with as a grad student. Uranium also. Uranium goes between like 2 and 4 and 6. But yeah, generally that's beyond the scope of the class. For this class, all you need to know is that metals tend to get rid of their electrons, and so they become positively charged. And non-metals tend to collect as many electrons as they need to get to an octet, which makes them negatively charged. But in theory, you can do anything you want. Actually, there's a good one. Hydrogen. Hydrogen's a really good example. Hydrogen, you can get rid of an electron, or you can give it an electron. It'll do H plus or H minus. Both of them are pretty common. What is chloroform? We're going to go over that actually in Unit 10. We're going to draw Lewis structures for simple things. I mean, chloroform is a very simple compound. There you go. You can look that up on Wikipedia. Like, all of these formulas are out there. All right, last call for any, like, review questions in terms of, like, content for, like, Unit 9 or Unit 8 or whatever. Now, regarding Wikipedia, anything that is science-based on Wikipedia, there is like a 99% chance that it is fine. And the reason for that is because scientists are extremely anal about this shit. So if there's a mistake somewhere on the internet, they are actively losing sleep over it. So like that sort of thing. F2021. That sounds terrible. Foof. That sounds like an awful compound. It makes ice burn. Yeah, I'd believe that. I would absolutely believe that. That probably destroys ice into like hydrogen and oxygen. And then combusts them. I have a few chemicals that I will never touch. Mostly anything with mercury and an organic compound in it, so a methyl or ethyl mercury, do not touch. Extremely deadly. Like a drop will kill you. I know of somebody who has passed away because they got a drop of that passed through a glove and absorbed into their skin, and within 2 hours they had died. Anything like a perchlorate is super explosive. Do not want. I mean, I did uranium chemistry. I worked with uranium, and uranium is like hardly an issue compared to some of these chemicals that are out there. Like methyl lithium is dangerous, but I've worked with that. That just catches on fire. I personally have not had a lab accident. However, I have flooded the lab multiple times. So I don't consider flooding the lab to be an accident because it's just embarrassing. There's just water everywhere. Not like you have destroyed the lab or possibly like injured yourself. None of those, thankfully. I've never even injured myself in the lab. Like, that's what I think is weird. I've done this forever, and I don't think I've even cut myself on glassware. I've dropped tons of glassware. I've definitely burned myself. Because hot glass and cold glass look exactly alike, and if you aren't paying attention, like, of course you're going to burn yourself, so. I mean, it's an online class, so, no, with the pretense that I'm not going to authorize it. You can do whatever the hell you want to, right? I probably shouldn't have it on record that I'm authorizing you to do whatever you want to. So just to be clear, I'm not condoning that you do anything of an explosive or dangerous nature. But I'm certainly not going to like prohibit you from living your best life, right? So on that note, I think that that's good enough. So I'm gonna just tab over to the title card here. Yeah, I mean, like we can do like random Q&A. You can hop in the Discord and ask me more questions. I'm always happy to answer stuff. Setting off explosions would be your best life. I mean, it's all it's a matter of perspective, right? All right. I do want to thank everybody for coming out to the lecture. As short as it was, there's really not much to talk about for this week, given that we just had a midterm. Make sure that you get quiz number 4 done. Last call is tonight. And then I'm going to put the lab worksheet number 3 assignment up on Canvas, and the assignment will be available for you to turn in stuff pretty shortly. I'm going to go do that right now. So, all right. That's all I got. Have a wonderful weekend and enjoy Halloween. Don't eat too much candy corn. Or eat all of it. You know, your best life, right?